Here's the outline. We're going to first demo the full life cycle of a burnable payment through Toastycoin, and that's going to be on the Ropsten network. So we'll be using fake ether. We'll go over the game theory that makes the burnable payments work. I'm going to open up a real burnable payment on the mainnet for work I need done relating to the first seminar's bad audio quality. So I'm going to actually use a burnable payment for something I need done. After all that, we're going to talk more about what it means to be a cryptoeconomic primitive and how specifically burnable payments enacts those sorts of principles. And then we're going to talk a little bit about what other possible cryptoeconomic primitives we could make or that are out there, and do some question and answers. All right. So once again, I'm going to go to MetaMask and make sure that we're on the Ropsten network, so that way we can mess around and not worry about spending any real ether here. And I have two accounts. Well, I have three accounts on here, but the two that I'll be using is Test Alice and Test Bob, just so we can have two identities to work with. So let's imagine that Alice has some work that she wants done. So she's going to go and create a burnable payment. And there's a nice usability thing here. If you double click, it autofills from the first from whatever account you have selected. So that's a nice little interface trick that I suggest other people use if they have some field where you'd usually want to use the main user account, but you might not want to. So that way you can still give them the choice, but make it easy to put in their address. So this is Alice's address. She's going to be the payer of this burnable payment. And let's imagine she wants a video transcribed. So transcribe video. We can say it's a 15-minute video. So there's some video out there that she has in mind, and she wants someone to transcribe it. She wants someone to write down the text of the video there. And she can put more information in here. In fact, she should. We'll talk about the game theory later, but whatever she puts in the title and then in this initial statement is going to be some important clues for the worker when they sign up to know how to satisfy her. And as we'll show later, the worker will actually be incentivized to satisfy whatever that request is. So she might say, well, she'll probably give that URL, some URL. And then she might say, please skip any ahs. Usually when you're opening up a burnable payment, it's a good idea to put some sort of deadline. So she might say, let's see, what's today's date? Today's date is the 27th. So she might say, finish the work by July 1st. And it's also good to say how they should deliver the work. So she might say, finish the work and post a link as a worker statement. And we'll get into what that is after I create this and we go through this a little bit more. And then she might say, if there is no work submitted by July 1st, I'll burn the payment. And she might also say, if there are errors, I'll burn some small amount relative to the severity of the errors. So the text here, you want to be specific. You don't need to be as specific as a lawyer, but you're kind of inching up to that, to where you do want to be pretty specific. So let's see how much ether I have in Alice's account. I have 0.4, and it's a 15-minute video. Let's say she's going to pay, I don't know, $80 for that. So that's about, that is a little under half of what I have here. So I'm just going to say 0.2 ether. And this amount here is actually going to go into the burnable payment. So when I click create on this after filling the rest of these out, we'll see the money disappear from MetaMask. It will actually be in the smart contract of the burnable payment that's created. And the service deposit is another ether value. She is not putting this value into the burnable payment. She's actually just, that's the amount that the worker would have to put in to commit. And we'll talk more about that later, but for now I'm just going to put in 0.1. And auto release timer, I'm going to put it 7 days, and we can talk more about what that means later. It'll be easier to explain once this is actually created. So now this is a dApp interface, and so when I click this button, it's going to call a Web3 function, and that's going to pop up MetaMask, and we can adjust the gas stuff here if we want. If we want to make sure it goes quickly, or if we want to try to lower this gas fee, we can do that. But I'm going to leave that all for defaults and confirm. So as it says here, we're waiting for a transaction to be mined. We can watch this area. We can also watch on MetaMask. Here it says submitted, and you can see the one before it says confirmed. So we're waiting for this to turn into a confirmed, and we should see both this area and this change at the same time, and that will indicate that it's been mined. If we click on this link now, it'll just bring us to Etherscan, and we can watch it here as well. So there's 3 different places we can watch it. You know, again, all this is happening on the Ethereum network, and you know, there are different tools to actually view that process that's going on. So we'll give it a second here. Earlier when I said we could change the fee, occasionally Ethereum will be sort of clogged up, and if that's the case, you can increase the gas price here. That's what we could have adjusted, and for 4 gigaway, if that's not enough to include it in the next block, maybe if you doubled it or tripled it, it could have made it go faster. Sometimes I like to go to the main Etherscan link and just look at these blocks, so we can say this one is about a minute ago, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 7 minutes. So we shouldn't have to wait too long for this to be included. While we're waiting, I suppose we could go look at the code that this page uses. Let me just do that. GitHub, Crypto Primitive, Toastycoin Frontier. And we want to look at the script. I mean, we're on create HTML, but if we click there, we'll see all the code, or all the JavaScript is within a script file. Create that JavaScript. And this is the function that is called, I believe, or no, well, it's this one and this one. So this one is it's bigger. It's not that interesting. It's actually just doing some sanity checks and some conversions, and eventually calls call new BOP with all of the converted values. And here's where the Web3 is actually called. So here we have a contract instance. And tomorrow or later today, I'm going to upload a video, and that'll be the seminar 1-2, and that'll talk about how to actually create this object. But it basically just represents a local handle to the actual contract, and then we call the new burnable open payment function of the BOP factory. Or sorry, and this should be. Sorry for the confusion. This is an older version of Toastycoin. This should just be BP. This O is part of an old terminology. So we could imagine this is BP factory, which stands for Burnable Payment Factory. And if we go and look at Toastycoin's Solidity source code, we can see that there's actually 2 contracts in here. One is again, ignore the open. One is the burnable payment itself, and the other is actually a burnable payment factory. And this factory just makes it easier to spin off new burnable payments through a smart contract function. And so this function right here, this function new burnable open payment, is what's being called on this line right here. And that is actually, so that's sort of the bridge from our website directly to the smart contract, and then it passes on, all the relevant information. Oops, I need to get back here. And then, as I said, that in this code, we'll forward it to the new burnable open payment, which actually is what creates it right here. And this is where all the logic of the burnable payment itself goes. All right, so our transaction is not yet included. I guess I should have increased the gas price. Have there even been any more blocks? Yeah, there hasn't been a new block yet. So occasionally when you are waiting for something to be mined, it just takes a while for the blockchain to mine a new block. So that's what we're waiting on now. I guess while we're waiting, I could go back to try to hunt down where we actually make this variable. And I'll go over that in the seminar 1-2 video, but I haven't made that yet, and nothing else to do while we're waiting, so I'll go over that. Let's go. Let's find where would that be in here? Maybe in utils. And this is the function that makes it. I wonder if that's in here. I bet it is in create. Care. Nope. I guess I can. Is this done yet? No. How annoying. Oh, here it is right here. So to create this contract instance that you can then call the smart contract functions through, you need two pieces of information. As I said before, you need the address right here, and you need the ABI, and these are defined as constants elsewhere in the code. But that is the crucial step that you need to actually be able to call the function in create right here. And then before any of that, you need to prepare Web3, which is another set of another few lines of code that you would need to do in any dApp. Oh my goodness, this is embarrassing. I wonder if I can just. Oh, it just got created. It just changed just then. Or maybe this just never. Well, in any case, it got created. We can see it there, and if we look at MetaMask, we'll see it's confirmed now as well. So Alice has made this payment. We can click here. It'll bring us right to the Toastycoins Interact page, pointing to this address specifically. And we could also find it on browse, and so let's actually do it that way. I'm going to close all of this and close this and go to browse, because this is how. So now let's change from Alice to Bob and imagine we're a completely different person on a different computer, and we are looking at Toastycoin for work to find. And there is our video transcribing burnable payment, and Bob could see that there is 0.2 ether inside it, and he can also see that the service deposit is 0.1 ether. Now what that means is that the service deposit part specifically means that if Bob wants to do this work and claim this 0.2 ether, he has to himself put in the 0.1 ether. We'll get into the game theory of this a little later, but for now, that's the basic trade-off that Bob is looking at. If he puts in the 0.1 ether, he has a strong chance of gaining this 0.2 ether as well, as long as he actually does the work. We can also see on this page that the payer is set, but the worker is just some null address. Again, that just means there's no worker. So I'm going to open this, and we can see the state here is open, and because it's open, anybody viewing this has this button here, this commit button, and it shows a service deposit right there. And as we said, Bob thinks he can do this, so he's going to go ahead and commit. And again, MetaMask pops up, and again, this is just calling another contract function in the same way we just showed earlier in the code. There's a contract instance in the JavaScript, and you just call a function, and then MetaMask takes over once that is actually called. And so we're going to go confirm. And I should have increased the gas price rather. But we can watch that. Sometimes they go pretty quick. Another thing is that we can see for any burnable payment, there is sort of this history going down, and these are generated from events that are logged in the smart contract. So if we go once again and we look at the code of the burnable payment, and I should blow this all up a little bit. There we go. So let's see here. So a payer statement, for example, let's just look for that piece of code. There's an event we define as a payer statement, and it takes as an argument a string called a statement. And if we go look for the next one here, that is where it's actually called. Well, it's called twice. It's first called when it's created, but you can also explicitly make another payer statement. Let's go down to that function just to show how that works. So there's a function in this smart contract called log payer statement. Only the payer can do it, and this is a modifier, which we haven't gotten into too much yet, but if we scroll up here, we can find this modifier. See, modifier only payer. A modifier is a way of just adding some extra requirements to the function. You can see here it requires that the sender of this call is the payer. This underscore represents that that's where the main body of the function should be run, whatever's being modified. So there's our modifier. We also have a modifier for in-state. So this, whoops, I didn't go back to the right place. Where were we? I was looking at not only payer, but payer statement. There we go. So only payer, and then they just payer statement, and that's just calling the event. So that right there is what actually emits the log, and that is what this is picking up right here. And so equally in the same way, you know, this and this, these are each events that is emitted in this smart contract code. And as I said in Monday's seminar, the ability to define events and then emit events, in the newer versions of Solidity, this line should start with an emit keyword. But when I wrote this, that was not necessary. But in any case, this is an event, and we're emitting it right here, and that is how smart contracts communicate with the outside world. And there's other ways too. I mean, you can have some getters and stuff, but this is a way for the smart contract to notify anything that's watching it for certain things. So I try to put events in any kind of action that a smart contract does. So you can see there's a funds recovered event, there is a funds added event, funds burned, committed. These are all events. And in the newer versions of Solidity, this would be more clear because there would be an emit keyword at the beginning of each of these lines. Okay, hopefully this is done, and indeed it is. That's great. So now, and we can see this has changed. I like to catch it when it changes just to see everything that's changed, but I'll just go over everything. So first of all, the state is no longer open, it's now committed. There's also 0.3 ether in there now, and this arrow is misleading. If I was going to redesign this, I would change the way this arrow is what it's implying. It's implying that all of the ether came from the payer, when in fact only 0.2 ether came from the payer and the other 0.1 ether came from the worker. I'm going to refresh. This list down here doesn't refresh right now. There's lots of ways that I could improve Toastycoin. But here it's clear. See 0.2 ether deposited by the payer, and now 0.1 ether deposited by this guy, which is the worker, and the worker committed. And again, these are both events that are emitted in the code. When the worker commits to the BP and the burnable payment, it changes from open to committed. And we can also see that instead of a commit button, we now have an indication of how much has been released and how much has been burned, which right now is 0. And we can also see the auto releases started counting down. So I'll try to go over a lot of this. There's 3 states in the burnable payment, and I can show that in the code here. There's open, committed, and closed. Closed is kind of boring. It just means that there's no more money in the burnable payment, and we'll see that at the end here. Open and committed are really the only interesting ones. We've already seen open. It's open when there's a payer, but there's no worker. And when the worker commits by putting in their whatever the service deposit is, which is what Bob just did, then it moves to committed. And certain logic can only apply to the burnable payment in different states. So now that it's committed, one important thing to note is that if I go back to, let's change back to Alice. I have some buttons here as Alice. I can add funds, which I could have done when it was open. But one thing that I can no longer do, there used to be a button here, and I don't think I showed it, but there used to be a cancel burnable payment button and recover funds, where if I clicked it when it was in the open state, I could take back all the money and say, never mind. And but now that there is a worker committed here, I can no longer do that. I can only release the payment, and in which case it will all go to the worker. Well, not all of it. I can specify how much I want to release, or I can burn, and in the same way I can burn a specific amount. And the fact that the payer has this choice, the fact that Alice has this choice of releasing or burning, means that Bob over here has an interest in satisfying Alice, because he knows he still runs the risk of motivating Alice to burn the payment. If Bob doesn't know anything, he can reason that she's probably going to burn the whole thing. Whereas if he does do it, then she's going to release it. And if Alice could still recover the funds, then Bob wouldn't really have a sort of any kind of strong game theoretical guarantee that she wouldn't do that. We would expect that if Alice is selfish and Bob commits, then she could at any time take back the money. So right now in this committed state, we have a very interesting dynamic here, where Alice knows that Bob is going to be motivated to satisfy her, and Bob knows that Alice can't get the money back, and she can burn it, but she's not actually motivated to burn it unless Bob somehow pisses her off. And then a final note up here is we have this auto release. I'm going to sign back into Alice and show how this looks from her. Oh, I am signed in this. Oh, and we have the button here. So Alice has a button, delay auto release, and this is another smart contract call. She can do this as many times as she wants. And if you remember when I created the burnable payment, I selected 7 days as the auto release interval, and so you can see it started to count down here. And whenever I click this, that'll reset to the full 7 days, and I can do that as many times as I want. I should say Alice can do that as many times as she wants. But if she ever lets this run all the way down, then this will be replaced for the worker. Let's sign back into Bob. Whoops. If this ever, oh, and I should probably refresh here. If this ever runs down, a big button will appear here saying trigger auto release. And Bob can then click that and then actually just take all of the money out of the burnable payment. And that's just an additional guarantee for the worker that if Alice opened this payment and then let's say she died, or she lost the private key, or she just forgot about the payment, then Bob has the guarantee that unless she's sitting there delaying this auto release again and again, eventually Bob can then take all of this money out. And that just gives a bit of a stronger guarantee to the worker that they do have some sort of claim on this money. Okay, so now we're logged in as Bob, and Bob has he saw the title, he saw this description, and he says I can do that, and that's why he's clicked commit. And we can imagine some time has now gone by. So Bob we'll just assume that he's done the work, and we'll get in later into why he is motivated to do the work, but he's done the work. And so now he's going to say, okay, I did the work. Another thing that's changed is that because this is committed and because we're logged in as Bob, that's why we have this this input statement here. Any other user wouldn't see this unless they were the payer or the worker. And if you're the payer, you would see a log payer statement button over here with the same text box. Anyway, so Bob's going to say, here's the work, and he gives a link, just an URL dot whatever, and he logs that. Confirm. And we don't really have to wait for this. I'll just tell you what's going to happen when it gets mined is that just like there's a payer statement here, there's going to be a worker statement appear here that that anybody viewing this can see, and it will have the text here where Bob is saying he did the work with the URL to the work. So as I said, I'm not going to wait for that. I'm going to sign into Alice. It's interesting, something was rejected. I don't know what that was. I'm not going to worry about it. And I wonder if, let's just refresh just to see if that has shown up. So it still hasn't been mined. But once it does, Alice will see the response there. She'll see the link. She'll go check it out. And for argument's sake, let's say that the transcription work that Bob has done is it's pretty good, but there's some mistakes. Let's say he made some spelling errors, maybe he missed a phrase or two. So it's in Alice's interest, and again we'll talk more about why that is later, to actually punish Bob slightly for doing a subpar job. So she's going to say burn 0. Of the 3, let's burn 0.01. So it's like 1/30th of the payment. And you'll notice this is a little bit misleading in the current use case because it looks like we're doing something with $0. And that's because we're just sending a command to the burnable payment to handle the money that's in the burnable payment itself. So this $0 is just symbolizing that Alice is sending 0 to the smart contract, and that can throw you off because you should think, well, but I'm telling it to burn a certain amount, and that's true, but you're not actually sending any money to the smart contract. You're just giving it a command to perform some action. And so I'm going to confirm. And then we're going to go ahead and release everything else. Once again, imagining that Bob has done the work, but it was just kind of subpar in some way. So the rest of it's going to be 2.9 and release and confirm. Okay. And we will wait for these. Maybe watch them on Etherscan. Bob's statement is probably down here now. Yep, and there's his statement. So I got mine. And once these get mined, this should auto-update this middle part here. And pretty much each one of these buttons goes to a specific function in the burnable payment code, and I could just go over those briefly, or really just show them to you guys. I'll just scroll through this here. Let's see. So commit, at the very beginning when the worker hit commit, that's what they did. It's public, and it should be in the state open. It should be payable because they need to be able to put the service deposit in. And you can see that the logic here is pretty simple. There's, if there has been an amount included in the commit, then you should put the funds added event. There's an amount deposited variable that just tracks how much money has been put in, so we're going to increment that. Set the worker as the sender of the message because they've committed. Change the state to committed and emit the committed event with the address of the worker. And there's a burn, which uses the internal burn. There is a release, which uses an internal release function. But you can see all of these are really very simple. And there's the end of the burnable payment. So there's not a lot of logic going on in here. And near the end of this seminar, I'll talk about what makes a cryptoeconomic primitive. But that's one of the key aspects, is that it's as simple as it can be. With and still perform whatever its functionality is. And we just have some members up here. We have all these events, and we have some modifiers, and that's all there really is to a burnable payment. And then the constructor here that just sets all these variables. So this is mined now. So now if we go here, indeed, so now it's closed. We can see that 10 milli-ether has been burned. 0.29 ether has been released, and there's nothing left in the burnable payment, so it's gone to a closed state. And I think often the payer will, if they'll say something about how it went. So they'll say, I burned 01 because you missed some phrases, or whatever the issue was. I released the rest. Thanks. And we could just log that statement, confirm. And the reason that a payer might do this is just to sort of maintain a reputation for being clear about why they have done certain things. And we can see these last events that have gone on. So that's the life cycle of a burnable payment. Someone like Alice comes along and they go to the create page. They have something they want to get done. They put in their own money. They specify how much the other person should put in if they want to become the worker, and they specify an auto release timer, which could be anything from, I say days here, but you can put a fractional amount if you want to do some hours, or you could even put something like 2 years or something like that if you want. They'll all work, and it just changes the rules of the game for the worker. And when you're creating these, depending on what values you put here, you will attract different kinds of workers. And Toastycoin and how it's built right now, and burnable payments, they're not easy to use, and they're not very intuitive. But that's just because we've developed it as the cryptoeconomic primitive. If you were to narrow it down to a use case, for example, if you were to build another interface that used the same burnable payments, but it was branded as a virtual assistant finder, then you could ask much better questions. Like, instead of title, initial statement, payer, payment amount, service deposit, you could say, how long do you need the virtual assistant for? Or and other things like, do you want an expert, or do you want just a basic Googling? And then the interface could take that information and then sort of generate some values for these kind of weirder questions, and then create the burnable payment on behalf of the user. So the motivation behind making Toastycoin was not exactly to make a commercially successful tool. And no one uses this right now, and that's okay with me. The intention was to demonstrate that these burnable payments can be used to do sort of anything. And in fact, if you want to check out some of these burnable payments, if you go to the main network, then you go to browse. Some of these have some pretty interesting stories. So my favorite one, I'll just do a Control F. This one, I was able to get someone to put money into my account, my bank account, and effectively do a completely decentralized currency exchange without any other systems. And I hope this event log loads here. Sometimes it takes a while, and this happened a while ago, which seems to make things take longer. But already we can get some indication of how this went. And again, this is on the main network. So there was 0.9 ether put into it, and again, this arrow is misleading. Some of that came from the payer, some of that came from the worker. And again, I was the payer. I don't know who the worker was. I'd never met them before. But we can see that all of it was released and none of it was burned. So that already kind of indicates that it went pretty well. And so here in the beginning, I created it with 0.6 ether. and I don't remember how much that was at the time. I wonder if there's a... Okay, so $185. That's what the amount was here at the time. So here I give some more information. I say I have some banks you can put it in, or you can meet me. I was in Cusco, Peru at the time. Email me after commitment, and we'll talk about how, I'll give you the relevant details like my bank information. And then I say that they should deposit no more than 1 week after commitment. I also say we'll use the price of Ether upon commitment as reported by ethereumprice.org. And then here is where the worker committed. And he made a statement there, sent email to get information. And on my side, I got the email. And now in between this event and this event, it doesn't show up here, but we were emailing and texting back and forth. And I was able to eventually get him my bank info, and he actually put the dollars into my bank account. So this is interesting because I was able to open up this burnable payment, put Ether inside it, and then just wait. And this guy, who I'd never met before, showed up and committed. And I should also say that when I opened this, it was part of maybe 7 or 8 other burnable payments. A lot of them you can read about in here. And then when I made them, I made a post on Reddit telling people that I was going to be doing this experiment with burnable payments. And so that was how, at that time, I got over the issue, the fact that there's no users here. I made a bunch of burnable payments, and then I popularized it on Reddit. But in any case, once I got that exposure, I didn't have to do any further work, and the worker signed up for this, and they had to put in his own 0.3 Ether. And if 0.6 Ether is worth 185, then that means he put in something around $90, if I'm doing my math right, $92 or $3 worth of Ether in there, just to have the chance to perform this service. And if I recall, let's see here, I believe what I did is, I said deposit 0.5 Ether worth of USD, and I actually put 0.6 Ether in there. So that was my way of including a little bit of a fee to him. And anyway, so he put the money into my account. As I say here, there were some issues putting the money into my account, so I decided for this extra effort, I'm adding a little bit of Ether before releasing, and you can see that here. I deposited, I released it all, and I closed the payment. So that that's a little bit of proof that these work. I'll get into the theoretical proof in just a second, but I want to just first make the point that aside from the theory, some of these worked out really well. Some of them didn't work. This one's kind of funny. I asked for someone to make a satanic video worshiping game theory. And if this loads here, I'll wait for that to load. As you can see, I released most of it, and I burned a small amount, and that was because they didn't do it by the deadline. So I burned that amount, if I'm recalling correctly. The deadline has not been met. Oh, here's some more information. I just say what I want them to do. It's basically just record a video in a burning pentagram hailing game theory, and so they committed, but then, as I say here, the deadline has not been met, so I burned a little bit. I burned it. Then they said, here's the link for the video, finally, so we can go look at that. And I don't think you guys have sound. I wonder if I can just fix that, just to make this... Oh my goodness. Hold up. I guess you can hear it on my computer speakers. That's good enough for now.
Game theory. All hail game theory.
So, that's kind of crazy and silly. I got this guy to make a weird YouTube video. So, when I opened up all these, I was trying to test the limits of the system, and also demonstrating that can work sometimes, and some of these didn't work. For example, there's one with spray painting where he actually did do the work. What? Spray painting. It's not on here? It should be... Let's see. That's interesting. It's not, so I think I just encountered a bug. There is a burnable payment where I asked somebody to spray paint an Ethereum wizard, but it seems like it's not showing up here, and I suspect it has to do with fetching events. This list here is populated by looking through events of the factory contract, and in the past I've had issues with that because MetaMask connects to a third-party node. Oh, there it is right there. So it showed up this time. So this one, you can see most of it was burned, and just a little bit was released, and that was because I actually I burned the entirety that was in the payment because he failed to meet the deadline and didn't update me at all. And then later he finally did what I asked him to do, and you can see I've reset the auto release timer a couple times, reset it again. Finally I burned it all, payment closed, and then he said, hey, wait, here's what it is. And so I kind of said, you should be ashamed of yourself, but I'm going to add a little bit and re-release it. And so I put something in, payment reopened, I released it, payment closed. He said, thanks. And y'all can read this in more detail if you want, but that's an example of where it didn't work out. So I guess all that is just to say that these burnable payments, they're not a silver bullet, but they are an interesting tool. And I would say out of all these that I opened, maybe half or 2/3 of them worked. But again, I was really trying to test the limits of the system. Okay, I'm going to stop there just for a minute or two and see if anyone has any questions. And then if after those, or if there is no questions, I'm just going to go over the game theory of it. I don't want to, again, you can read this, and I have a link again on my on the CP Academy blog. If you go to the cpacademy.io and then you go to blog, here's the link to this game theory that I'm about to go over. So I'm not going to go over all the text here, but I'm mostly just going to focus on these images, which is using, this is called a game tree, and we're going to be using backward induction to go up this, this tree here. So I'll give it a minute or so and wait for questions. Oh, I'm disconnected from chat. What's going on? I wonder if I've been missing anything in the chat. Okay, all right. So I don't want to spend too long on this. I'd like to pretty quickly get to discussions of the general concept of a cryptoeconomic primitive. I'll try to get through this pretty quick here. So this is a game tree, and you can use game trees for actual games like chess or checkers, but you can also use it for the game theoretical games as we have here with the burnable payment. Here we have 3 turns. We have the payer's turn, which there's only one thing that they can do. They can create the burnable payment. These images, again, they say BOP. You can just ignore the O. I'm always talking about burnable payments. Again, that's a standby from, as I say up here, they refer to burnable payments as BOPs. That's not what I call them anymore. Anyway, So the payer starts by creating a burnable payment. Any given worker has three choices when they see that open burnable payment. They can, of course, they can just not commit. They could also commit but not do the work, and then they can commit and actually complete the work. And then in each of these first two cases here, B1 and B2, the payer can release or burn. So then there's 4 end games here. Well, there's really 5 because B3 counts as an end game as well, as I say here. So the first thing we can talk about is we can sort of cross off 2 of these end games. And when we use backwards induction, which there's a link here that talks more about backward induction. But backward induction basically amounts to looking at every single end game possibility and crossing off the ones that the payer is never going to choose, or the last player is never going to choose. So in this case, let's look at B1 and C1 and C2. So if the worker commits but they do not complete the work, it's unlikely that the payer is going to release. And I mean, we could say that the payer is just going to be angry, but that's not a very strong game theoretical reason. A stronger game theoretical reason that is still just as valid is that the payer is not going to release when the worker commits but does not complete the work, and the reason for that is that he's going to be mindful of his reputation. So if Alice comes up on here and she opens up a burnable payment, and someone commits but they don't do the work and she releases anyway, what she's doing is she's indicating that she's going to be that she releases for workers even that don't do the work, and that's just going to attract more workers that don't intend to do the work, and that is going to make the tool less effective for Alice. So even if she is completely emotionless and she actually doesn't bear any ill will toward a lazy worker, she still has it in her interest to not choose to release. Because if she does release, it's going to make it a less effective tool in the future, because she's built a reputation that says, you know, if you commit and don't do the work, I'll still give you the money. So it's in her interest to burn the payment instead, because that sends the opposite signal, which is to say, if you commit and you don't do the work, I'm going to burn it. And that builds a reputation that will dissuade anyone that intends to commit and not do the work. So in the case of the worker choosing B1, it's extremely likely that Alice, or the payer, I should say, is going to choose C2. And we can do similar reasoning for this whole section of the tree here, where if the worker commits and completes the work, even if Alice is completely heartless and doesn't bear any goodwill towards the worker, she's still going to choose to release it, because that will build a reputation that she releases for completed work, and that, again, will make the tool more effective for her. Whereas if she burns after the worker had committed and did the work, that is going to build a reputation that says she burns in any case, and then no one will ever commit to her payments that she opens, and that will make it the tool less effective. And so now here's where the backward induction aspect sort of starts to play in. Because we've crossed off, we've sort of looked at the last turn and reasoned about what the payer is going to do in every single case. Then we can move up a bit, and we can say the worker, looking at his turn, he has these 3 choices, and if he knows, he can sort of reason, as we've just done, that if he commits but he does not complete the work, he can expect Alice to burn the payment. If he commits and completes the work, he can expect Alice to release the payment. And then, of course, he can just end the game before it even starts by not committing. So those are his 3 choices. But because he knows that if he chooses B1, it's likely going to be ending up in C2, where the payer has burned the money, and also because the worker by this point has already put in a service deposit, that will end the game in a negative payout for him. He will have put the service deposit in, and then he won't get anything out. And so that's a negative outcome for him. And he knows that if he commits and completes the work, he at least gets the payment. And if he doesn't commit, then he doesn't get any payout, and he doesn't suffer any penalty. So we can say that in any case, he's not going to choose B1. And so we can cross off this, and we can cross off this whole section of the tree. And so here's where we get to why a payer would create a burnable payment in the first place. Because when you look at the game theory of this, you can sort of reason that if you create the burnable payment, only 2 things are really likely. I mean, assuming that the workers are rational, which is it's an idealization, but it's a pretty solid one. And you can reason that either the worker will commit and complete the work, or they will just not commit at all. And if they don't commit at all, of course, you can recover the money. You can take it back. It's only when they commit that the payer is actually committed to spending the money, whether it's burned or released. And so if you, there's some loose ends I won't go over relating to, for example, what if the payer doesn't care about the reputation, and that's actually why there's a auto release feature. But you can read this if you want. I think that's enough of an overview for the game theory of the burnable payment. One last note is that because this game theory is relatively solid, we were able to create if I just go back and look at this code again, the code, whoops, that's not what I wanted. I wanted to go here. The code of this is relatively simple. You can see that I never nest further than, like the function and then one control structure in. I never nest further than that. The logic is extremely simple here. And this is still an effective tool because even though there's no complicated logic in this burnable payment, the game tree that it results in and the game theory and the incentives actually incentivizes really good cooperation. And I think that is something to be desired when you're designing smart contracts. If you can design solid game theory with simple code, that is going to, I just think that's a more direct route to making tools that are useful. And I think it will turn out to be a common aspect of any kind of cryptoeconomic primitive. All right, so that is the game theory. I'm going to close out that and go to the next one. Oh yeah, so I'm now going to open up a real burnable payment with Ether. If you guys have seen the seminar 0 and then the first seminar of this week, they each have really bad audio, and that is because I was using the built-in microphone of my laptop, and I didn't realize how shitty it was until after the first recording. And anyway, so that is an issue. I would hate to redo those videos. So what I am going to do is I'm going to go to create. Well, first I'm going to go to the main net. Oh, I'm already on there. That's cool. All right, and now I'm going to go to my main. I have a little bit of Ether on here, and I'm going to create a burnable payment for someone else to fix that for me. So again, I double click to autofill in with my main here, and we can just see that's the same, ends in F946, and indeed this ends in F946. Title is Fix Crypto Primitive Seminar Audio. Seminar 1 audio. Okay. And so what is it specifically that I want done? I know that there's ways you can filter out any kind of droning or constant noise, and I think that will be effective for this video. So I'm just going to say, see this video, and then I'm going to, video, and then I have to go find the video link. Here it is. Copy that. You can hear that. That's awful. God, I hate that. So, see this video. Okay. I'm just going to shut up and write this out here a bit. How do you spell that? Oh, no. Is that how you spell it? I guess. algorithm. Whoa, didn't mean to do that. Hit some F keys. Now, what I'm trying to decide here is I'd like for it to be largely removed, but I know realistically there's probably going to be some sort of artifact remaining. As somebody else said, it might end up making my voice sound more artificial. Also, there might be some kind of remnant of the wine. I'd like to be largely removed. So as a little bit of an experiment, I'm just going to keep it about that vague, like the sound to be largely removed. Understand there might be some minor artifacts as a result. Okay, and spell all my words correctly. Let's see. Please complete the work within 3 days after commitment. And actually, I'm just going to reduce this to 1 day because the actual work shouldn't take that long if one knows how to do it. I mean, you should just strip the audio from the video and do your processing and then re-upload. And then I'll just say, how should they deliver the content? I guess I want them, I could ask them to send me the audio, but then I'd still have to do the work of putting the audio with the video, which, I could do, but while I'm asking for work to be done, I might as well ask for a completed bit of work. So I'm just going to say, when you're done, upload it to YouTube and submit the link here as a worker statement. Okay, so that is my request there. Now I got to figure out how much I want to put in there. I believe that for someone with the right tools, this should be pretty rudimentary, pretty straightforward. I think you just have to sort of take a profile of the sound that you want to remove and then click some buttons or whatever. And of course, I'm probably underestimating the effort required. So I am going to put in, I guess, how much in dollars? I'm going to put in about $75 worth, which in Ether, I guess I need to do some math. All right, so Ether, no, that's not what I wanted. Don't want this one. Don't save. Want this one. Okay, so if I want roughly $75, that's about 0.172. So I'm just going to say 0.17. 0.17. And I found that the service deposit, if it's any less than 1/3, you don't have as good of a guarantee of a serious worker. So I'm going to put, let's see, I guess 0.6. That's roughly 1/3. So that means the worker's going to have to put in, let's see, that would work out to about, I don't know, $30 or something. And then they get a chance at getting their $30 back, as well as my original $70 that's in there. And actually, I'll make this a little lower, just because this bit of work, I don't think there's going to be much of a risk of scope creep. And I found that scope creep in particular really destroys the game theoretical guarantees of burnable payments. You know, if you ask for a large project that's going to have a lot of small bits of work attached to it, the worker can sometimes commit, and then they can realize that it's a lot bigger project than they want, and they would rather actually just move on and take the loss of the deposit rather than deliver the product and do all the work that would entail. But because this is relatively simple, I believe, I'm going to keep the service deposit kind of low. And I guess I can also say I recommend making sure you can do the work before committing. Okay. All right. Auto release timer. Now, because I'm making the deadline rather short, I could make this auto release timer like 3 days. But I'm hesitant to do that because Toastycoin and Burnable Payments doesn't have any kind of notification system yet. And that's because there's no server behind any of this. The only server that's doing anything is GitHub's server when they serve the page. But I don't have any kind of LAMP stack monitoring this. So actually setting up email notifications would require that I do set up something like that. So there's no notification service going on. So if I make this auto release timer too short, then I kind of have to check this burnable payment like every 3 days to make sure, okay, has someone committed? And because if they've committed and they don't do the work, then I don't want them to be able to trigger the auto release, because then that would build my own reputation as being an easy mark. So instead of 3 days, I'm going to put 7 days, and then create it. And as we can see, yep, about $70 going in here. And I'm just going to make this gas price a little bit bigger, just to make sure I don't have to sit here and wait like a doofus. And confirm. All right, waiting for it to be mined. I'm going to be right back. Give me just 2 minutes. Hopefully this will be done by the time I get back. Okay, I am back. Let's see if there's any questions. Yeah, so as noted here, it's been created. We can click and look at it, and we can also now find it if we want to go to browse. I also have another one open already to archive the Satanic Game Theory video, just so everybody knows. And that one has even lower service deposit, but it has to do with archiving the video on some sort of IPFS system. Anyway, so now we can find this on the browse. We can click on it, check it out. We can see that it's open, and now again, because I am the payer, I have this Add Funds button. I also have this Cancel BP button, and then anybody that's looking at this has this Commit button that they can click on. and we see that here's the events. So by using this burnable payment, by putting this out there, my money's in there. It's sort of acting as a bit of a bait and sort of, I don't know if anyone has seen the Mr. Meeseeks episode of Rick and Morty, but that's what this kind of reminds me of, is that I can put this request out there, I wait, and you know, if I've set these values in a way that's enticing, someone will just sort of pop up out of nowhere and do the work, and then kind of just disappear and go away. And if they actually do the work, I don't even have to come back here and click release. They'll be able to eventually click the button themselves. So, in a way, the burnable payments are they are achieving the same thing as sites like Fiverr and Elance and Upwork, but there's much more ease of use in this, and it skips a lot of the steps. I don't need to, as a payer, I don't need to go through and look at anyone's applications. And I can also do it for much smaller tasks. Instead, in fact, one of these was a bug fix. I hope I can find it. Bug. Yeah, so I had a bug on Toastycoin, and this guy solved it, I think, within like 24 hours after commitment. And so that was another case where, you know, I would have never opened up a job on Elance or Upwork to solve a bug, because it wouldn't have made sense. I would have had to go through applications and look through them, and probably no one would have applied to it in the first place, because not only as the work provider I would have had to go through the applications, but also the workers would have to apply to a bunch of jobs without even knowing if they'd get one of them. And on Toastycoin, it sort of eliminates both those issues. The payer can put money out there and just wait for someone to show up, and the worker can immediately sign up to do any work that they want and know that they have a pretty good claim on that. So anyway, so here's, you know, I had the issue on GitHub. I gave a little bit more info, and the worker even said, if this is accepted, I'm willing to bounce back point through Ether, because their fix was quite simple. All right. So anyway, I guess I kind of lost my train of thought there. Well, I guess so that I have the I have this burnable payment open. So we'll see if anyone signs up to do that. A nice benefit right now is that because I'm streaming this and I'm going to put the YouTube video up later, it sort of solves the, you know, one of the obstacles with Toastycoin is that there's no users on it right now. And you know, if I was dead set on making this commercially successful, that would be one of the main things I'd be looking at. But again, this is, you know, I'm happy with how Toastycoin went. I think it proved what I wanted it to prove. So that's not my main goal right now. But anyway, so this burnable payment has exposure. So we'll see if anyone signs up to do that bit of work. And if nobody signs up, I can always click on add funds. And I'm going to cancel when this next MetaMask thing pops up. But if I really want to, I can add, let's say, 0.05, and I click add, and then I can click accept here. I'm not going to do that. I'm just going to cancel out. But that is an option to me. So I have sort of two options. If this doesn't get filled, I can cancel it and to get the money back, or I can add funds and try to make it more attractive. Okay, so that is number 3. So I want to talk a little bit about burnable payments and talk about what makes them good as a poster child for cryptoeconomic primitives. I had some notes here. Let me find them. So there's two main aspects of a cryptoeconomic primitive that I'm pretty confident in saying that they're an essential part of cryptoeconomic primitives. The first of them is that they're non-proprietary. So to me, there's sort of two aspects of saying something is non-proprietary. First of all, it's non-profit. You know, in my if I go back to the source code of the smart contract, as I said earlier, I have a factory contract which makes these burnable payments. And within this factory contract, here is the part of this line where it's passing whatever Ether was passed to it and passing it along to the burnable payment. If I'd wanted to, I could have, here, I'll just copy this to a new text editor, new text file, rather. Oh, goodness, I hate how it does this. Okay, welcome. So, if I really wanted to, and this was suggested to me, and I was really considering it, I could have here, instead of just passing the value onto the payer, I could have said, you know, profit equals, you know, maybe message.value, I don't know, maybe like times 0.01 or something like that. And then I could have taken that, and then I could have said you went in BP equals message.value minus profit. And then here I could have said, instead of passing all the value, I could have said invested in BP. And so just as simple as that, I could have made this burnable open payment factory delivered to me profit. And I suppose I would have had to add another line in here, you know, my address, which that's not defined. I would have had to define this my address variable, but I could have transferred the profit. And just about that easy, I could have made this burnable payment factory sort of work for me and delivered to me a tiny sliver of profit for each burnable payment that was created. But there's a couple points to be made about that. First of all, this is no longer the simplest version of the contract that it could be, and I think that kind of violates the primitive part of cryptoeconomic primitive. That term pretty clearly, I think, implies that it can't get any simpler. And as soon as I start adding this extra profit mechanism, it's no longer as simple as it could be. Another, you know, sort of realistic fact is that as soon as I publish this this contract, someone just as easily as I put this profit mechanism in, somebody else can just go take it back out and publish their own. And when you look at those two possibilities, where we have one that has a profit mechanism and one that does not have a profit mechanism, from the perspective of a user or developer that wants to use this in their application, there's a clear winner there. I mean, the one without profit is simpler, it's cheaper to use, and it's also it has a certain neutral aspect to it, that nobody owns it. So if our goal is to make a cryptoeconomic primitive that we can depend on for a long time and build into a bunch of systems, we want something that's not going to change. And it's as simple as possible. So we don't want to have this profit mechanism in there. So that's one part of non-proprietary. The other part of non-proprietary is that nobody's trying to control this. So if you look at the GitHub for this whole Toastycoin and Burnable Payments, I have an unlicensed document in here, I think. Oh, maybe I don't. Usage. Nope. Well, I don't have it in here explicitly, but cryptoeconomic primitives shouldn't be controlled, I think, by any licenses. I mean, even the most open source licenses still tend to have some restrictions on them. For example, some of them say that you can't use it for commercial projects, or some of them say that you have to even when they require such innocent things as you have to give credit to the original authors, you're still in a minor way restricting usage. And again, if we're making these cryptoeconomic primitives, first of all, the reality of the situation is that anybody can go and copy your code and upload a smart contract, and there's no legal action that we can do to stop them. So let's start from there, and the fact that realistically, any smart contract that has the code published realistically is in a way unlicensed. And if someone makes something that they're trying to call a cryptoeconomic primitive, but they also try to limit the usage, it's going to harm that claim of a cryptoeconomic primitive, because we want these to be as usable as possible. So to me, those are the two parts of that non-proprietary I would say, requirement of a cryptoeconomic primitive. First of all, there's no profit being taken and given to some special party. And also, there's no special party that has any kind of special control over the primitive itself. Now, that's not to say that these cryptoeconomic primitives can't have notions of profit. In fact, as we talked about in the podcast from Hashing It Out earlier this week, you might have a cryptoeconomic primitive that is specifically geared towards some sort of profit mechanism. But the difference there is that primitive is not defined as part of its definition with a specific party in mind. It can be used by anybody. And so these primitives can deal with profit. But the key issue, what we want to make sure happens is that they don't come prepackaged with some specific beneficiary, because there's no reason to keep that in, and somebody probably will come along and just take that out and then make a more usable tool by doing so. So the other of the two main characteristics of a cryptoeconomic primitive is that it's highly self-sufficient. And what I mean by that is, let's look at these burnable payments again. I have a link on the blog post. It's this last one, or this second one. Wait, hold up. I guess I don't have it on here yet. I have it in my notes here. So I'm just going to quickly edit and put this in. So way back when I first came up with this idea, I didn't have an interface, so there was no Toastycoin or nothing like Toastycoin. And I just made the contracts themselves. They were right on Ethereum, and I told people about it. This was the first time I'd ever posted about any of this. And so what I did is I just told people what was in the burnable payments. I gave them the ABI here, so there's a link here. And then I gave them a link to the Etherscan of each contract. So with that information, any user could start reading out of this. And some of these worked, some of them didn't, but I think two, I opened up 4 here. And as you can see from the amount of Ether in these, this was back when Ether was like $50, I think, for each Ether. But in any case, 2 of these worked, and then 2 of them I ended up recovering. But the point here is that these were able to work without any other interface. These they served their purpose, which was they attracted workers, and they did it without anything except for a Reddit post. And so that's what I mean by when I say highly self-sufficient. The contract functions without relying on any kind of outside authority. There's no company it relies on. There's no email server it relies on. And certainly we can build tools that make it easier, and that's exactly what Toastycoin is. But when I say that a cryptoeconomic primitive should be highly self-sufficient, what I mean by that is that we should be able to imagine a world in which everything except for the smart contract and Ethereum itself fails, and still the cryptoeconomic primitive functions with game theory and users naturally being incentivized to play whatever roles that they're playing. So for me, those are the two aspects of a cryptoeconomic primitive that are important, and I guess I can just put that in here. Non-proprietary, which means no profit mechanism. No and then they are supposed to be highly self-sufficient. Okay. Let's see what else. There's a few other points about cryptoeconomic primitives that I am not as confident. I would say that these are, to my mind, and no one here is an expert, right? But to me, I think these will prove to be pretty non-negotiable for anything that calls itself a cryptoeconomic primitive. I have some other thoughts as well. For example, I think Cryptoeconomic primitive should be able to be used in other larger systems. I think they should be able to be used by not only users but by computer programs. And but these are the main aspects of cryptoeconomic primitives in my mind. All right, so the last point here, I don't know how much time I'll spend on this. It might not be very long. Let's see what time it is. In fact, I have to head out here pretty soon, so this will be quick. And I'll just start making a list here while I'm talking. So one thing that I've been working on a little bit, I call it a crowd serve contract, but the idea of a Kickstarter. So we've already seen Kickstarters that work by some centralized model. So it would be nice if we could make some sort of cryptoeconomic primitive that did the same thing as Kickstarters. ICOs. Well, first of all, an ICO itself is sort of a cryptoeconomic primitive, although I don't know if it should be more specific than just ICOs in general. Also, ERC20 tokens are cryptoeconomic primitives, but again, I don't know if they should be more specific. So we have ICOs, ERC20, ERC 223. 223 is just another token standard. I actually think it's better than ERC20. But in any case, these are both maybe cryptoeconomic primitives, but maybe we should get more specific before we call them that. But back to some other ideas. We could do a Kickstarter. Another thing we could do for a cryptoeconomic primitives is a subscription manager. And I think that this is actually going to be one of the very first contracts we work on, maybe even starting next week. And this is just a place where a user can put money, so I should say deposit and withdraw money into a smart contract, and billers can be approved to take money out, specified by some rate. So when you think about, for example, think about a bank account. A bank account kind of already fills this role where if I have $1,000 in a bank account and I have some routing numbers, I can then go and hand that out to certain billers, and I can know that they can take money out, and I don't really have to worry too much about fraud. And that's useful for me because then I don't have to go through the effort of making sure I'm up on every single one of my payments. I can just make sure that the one bank account is topped off. And as long as there's enough money in there, I know that all of my services are going to keep going, like Spotify, for example. I don't think I'm ever going to become so destitute that I won't pay for Spotify. So it's nice that I don't have to go and worry about that bill every month. It's nice to me that it is automatically taken out. But in crypto, we don't really have anything like that. So I think a great cryptoeconomic primitive, which again, it should be non-proprietary, it should be highly self-sufficient, is just a subscription manager. It's just a contract that a user can create their own subscription manager contract. They put money in, they can take money out whenever they want, and then they can approve certain billers to take out money at a certain rate. And so realistically, if we were going to make that, we'd want to design the contract, and then we'd want to also design, I would say, pilot interfaces, which we would maybe expect the community to then take and improve, but we would want to make an interface for the user, the owner of the money, and we'd also want to make an interface for the biller, maybe to request access or to actually perform the withdrawals. So that is I think that would be a great cryptoeconomic primitive to work on. We could also do an escrow. I mean, we already have some escrow systems that people use. I don't know if they are entirely encapsulated in smart contracts. I don't know if they're non-proprietary, but certainly we could make something cryptoeconomic primitive that solves escrow. And for some of these, like Kickstarters and escrow, these are general ideas that if we sit down and try to implement them in code, we might find that there's maybe 2 or 3 or more legitimate implementations of them that just take different design decisions. And so I think what we might find is that we, under the escrow idea, we might end up with 2 or 3 cryptoeconomic primitives, and we might have some code names for them, like escrow, alpha, maybe would be a very basic, and we might have an escrow, I don't know, I'm just making stuff up, but escrow multiple, where there can be more than one person playing the escrow role. And I don't want to go on too long. I'll just talk about a couple of others. Another one is there's this whole idea of identity management through contracts, where you can recover your identity by using different social mechanisms. So you have a smart contract that acts as your identity, and you can use it to interact with other contracts. And you have a few private keys that you can use it directly for, but if you lose those private keys, you have designated certain other identities on Ethereum that can help you recover it by sort of confirming, yes, this is this guy's new key pair. So identity management we could put on there, but that is, again, this is more of a class than a specific primitive, and then we'd have to figure out what the specific implementations are going to be. But I think that's it. I think I'm done now. I'm excited to get into this stuff as the Academy moves on. And I was just thinking earlier, I've been calling these streams seminars, but they're really more like lectures, because I'm the only one talking. And I would actually like to have some seminars, some sort of open discussion with the community, because a lot of this is just my own conjecture. And some of it I'm quite confident about, like this stuff up here. But some of it we just need to start discussing, and it needs to be more than my voice. So, as part of the Academy, I want to kickstart this off with the instructional aspect, and I intend to make that as strong as I can. But the other part of the Academy that I want to work towards, with some sort of seriousness, is the idea of it being a place of research, where we can take a vague list like this and say, okay, well, what's the first one to work on? And how do we get there? And what's that going to look like? All right, I think that is it. We got through all these points here. I will, I suppose, go back to the channel and make sure there's no unanswered questions. Although I think when I load this, it doesn't show me the whole chat. And I used to have something on my phone that would show me the chat, but it doesn't seem to be working. I'm going to go to the Slack and hang out here for a bit. David, were there any questions? Do you know? Did you see any? Oh, it looks like I forget first name, Corey. That's right. Looks like Corey, he's one of the podcast hosts. Looks like he maybe has already committed. Let's look here. It's still open. So, Corey, I would say if you're doing that work, I would go ahead and commit, unless you don't have the Ether, and then in which case you can just let me know when you've done the work, and then I'll just cancel the burnable payment here and pay you. And that actually brings me to another interesting point about these burnable payments. By opening this up, putting my Ether out there, even if, let's say Corey does this work and he gives it to me and I cancel the burnable payment and then I just pay him directly, even though nobody actually committed, and even though I canceled this burnable payment, in a way it actually served its purpose, which is it advertised that this money is really out there, and it's really out there for anyone to sort of claim if they want. So, oh, you know what? I did some math wrong here. The service deposit is way bigger than the amount in there. So that was my bad. I am going to just cancel this and redeploy and do that correctly. So copy that. I'm just just going to assemble this really quick. Okay, no questions. All right, well, I'm going to, I guess I'll just redeploy this really quick. Then I'll end the video. Okay, got the text there. Cancel. Confirm. Now I'm going to go back to create. And paste this. Get the title back up here. And the payment amount was 0.17. And I don't know where that, oh, I meant to put 03. That was the mistake. All right, and put 7. All right, create, and confirm. So again, Corey, if you want to commit to this, you can go ahead and do it. But if not, just let me know. Let me know when it's done. And back to my original point, even if nobody commits to this, if somebody actually just does the work for me, the Burnable Payment has really done its job, which is to advertise the fact that I'm willing to pay for this, and in fact, provably advertise it, because there's no way I'd open this payment up and actually put my money in there unless I want to pay for it, because I know that at any point somebody can commit to it and then claim that money, and then I've spent it, I can't get it back. So by opening up this Burnable Payment, I sort of provably demonstrate that this work is valuable to me and that I'm willing to put the money out there. So the fact that Corey is now doing this for me, you know, again, that sort of magically happened for me. I didn't need to go and seek out somebody. I didn't need to go ask a question on the Slack, hey, who knows how to do this stuff? And it's sort of happening for me automatically. And that, you know, that is what I wanted out of the Burnable Payment, whether or not it actually goes through the traditional life cycle or I cancel it. All right. Cool. I think that's it. I'm going to stop the recording.